Okay, students, happy to bring in another topic today. That is orthogonal set. Orthogonal set. What's that? Orthogonal set. Suppose Fi, that is F1, F2, F3, F4, like the sequence of functions, is said to be orthogonal. This particular group of functions Fi, where I takes a value 1, 2, 3, 4, dot, 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 like that. When they say that they are orthogonal, it has to satisfy two conditions. The first one is this, second one is this. What is the first one? What we call this an inner product. Okay, inner product. You are giving the notation like this. So the inner product of Fi and Fj. You must understand that Fi should not be equal to Fj. Okay, yeah. When Fi is not equal to Fj, then we say that it has to satisfy this condition also. Then we say that the sequence of functions Fi is called orthogonal set. When Fi equals Fj, what will take place? Its value is 1. Okay. When I equals j, then it becomes 1. The value of that equals 1. That is inner product of that equals 1. When I is not equal to j, the inner product equals 0. The second conditions integration Fix Fjx dx must be equal to 0. This is what the definition of we know that this is a definition of inner product, semi-correct. So you must note that these two conditions satisfied by this particular sequence of functions, then we say that this sequence of function is called orthogonal set. Okay, that's what one definition. Now coming to the second definition, now look at that. That's called Hamiltonian operator. What is a Hamiltonian operator? Okay, now look at that. If k equals integration a to b k of x comma t dt, if this particular what can I say is that operator satisfies this condition, that is the inner product of k f g equals the inner product of f and kg. Kf comma g equals f comma kg, then this operator we call it as Hamiltonian operator. This operator k equals a to b k of x comma t dt is called the Hamiltonian operator. Okay, now look at that. Now, so what is that Hilbert-Schmidt kernel then? Hilbert-Schmidt kernel is nothing but it must be a Hermitian and square integrable. A function is called Hermitian and integrable. Then we call it as it is a Hilbert-Schmidt kernel. Okay, so with that we come to the end of this program. In the next program I will take another topic. Okay, so in this topic we discussed about now orthogonal set. Second one is about Hamiltonian operator. It has to this operator satisfy this condition, and if a set is Hermitian and square integrable, then we say that it is a Hilbert-Schmidt kernel, because Hilbert-Schmidt kernel would be very useful to prove the theorem, Hilbert-Schmidt theorem. So understand well. Thank you very much, and we will be discussing that in the next other class.